Okay, so now we're going to look at university physics, chapter 10, the bridging problem, billard physics. So what this problem asks us to do is that we have a billard ball and a cue stick. So the cue stick would strike the billard ball at a certain place with respect to the center of mass of the billard ball. So there are two parts to this problem. The first part A, is to ask at what distance from the center of mass should the cue stick hit the billard ball. So that is how high from the center of mass, uh, such that the cue stick would need to hit such that the billard ball would roll without slipping. So that's the part A of this problem. Okay, so now we continue with bridging problem, chapter 10, university physics. So we have redrawn the diagram in this bridging problem. So we have a cue stick represented by the force F here, and a billard ball with a radius R. So the problem is asking us to determine the distance the cue stick is from the center of mass, such that after the cue stick strikes the billard ball would roll without slipping. So we want to invoke the no slipping condition. So the no slipping condition is that such that the center of mass, velocity of center of mass, is going to be equal to the angular velocity of the ball about the center of mass times the radius of the ball. So right after the force from the cue stick strikes the billard ball at a certain height or a certain distance from the center of mass, the ball should immediately roll without slipping. So this is part A of this problem. So what height h such that the ball rolls without slipping? And so the billard ball would experience an impulse from the cue stick. So we have the change in momentum is going to be given by the force times the time. Similarly, so therefore we can get the change in momentum of the center of mass motion for the billard ball, which is delta m v center of mass, and so this is going to give us the impulse.